Okay. I can't see any of you guys, sorry, but I know there were some names that were very familiar to me. I've been, like Laurel, been with Maxwell's for quite some time. Had a little sojourn out of the company for about 1.5 years and returned. My background is resource geology, which is pretty much the reason why I got into the data management side of things. After several instances of spending 3 months or so building all these beautiful resource models, only to have to throw them out and start again because the underlying data that was used in it was found to be invalid. And so I started spending a lot more time behind the scenes validating all the data and fixing that up, and then sort of thought I really enjoyed doing that. It sort of fits my sort of OCD tendencies, I suppose. But yeah, so assays and samples in particular are and QA/QC are the things I like to focus on. I spend probably the majority of my time at Maxwell's inside everybody's databases and having a good nose around and trying to find issues, fix issues, identify issues, all that type of thing. So I do probably 50% of my work internally is audits of databases. So gotten to know the inside and outside of the MDS pretty well over the years, and seen a lot of different databases, both on-premise and in our hosted environment. So I'm just going to request control, Laurel, so I can take the presentation.
Right.
Okay. Can you minimize your, yeah, thanks. Yeah, okay. Now this is a very simple, sort of really simplified version of where the process starts. And to most of you, this is going to be stuff that you do already and you know all about. It's more of a reminder, more of just focusing on what the basics are, because even today in some of databases, an audit that I just finished yesterday, there is a lot of data that's still not being collected correctly. If that's, sorry, collected correctly. That's a bit of a hard phrase. And I'm going to allude to here, and I'm referring to Table 1 of the JORC 2017 code. Now, everyone probably is familiar with what Table 1 is. It's a statement of what your data, you know, who did your drilling, how the samples were taken, how the assays were done, all that type of thing. And people write in there and sign it off, competent person, etc., etc. But what's happening is that that's not always being translated through into databases. So if someone comes to do an audit of your data, or if you're interested in getting investors and you open up a data room and people have access to your database and they're going to go and validate some of this information, it's not there. So this is a very simplified version of just taking it right back to that. Okay. So very simply, before we start, I'll talk about how it works in our MDS. There's a lot more than just collars and samples, obviously, but for the samples, it has to have a collar position before you can load the samples. That's all I'm alluding to in that first collar sort of box. We have a suite of several sample tables. You'll see I've added hyperspectral SAMP in there. That is the new sample table system we've got coming out in 466. Just for the same reason that we split the water assays out of the normal table assays, just because there were too many columns being added to table assay flat, and it becomes unmanageable, especially if people are still using Access, which has the 256 column limitation. So we've now got the 4 different sample and assay systems, and I'll talk more about the left-hand, right-hand configuration of these as we go. And each of these assays has its associated batch and batch details. I'm not going to go too much into the design around all that. If those that have been using Datashed understand all this. Okay. Simply, this is a really simple schematic of what should be collected when you're taking your samples? Obviously, we need the sample ID. I find in probably 90% of the databases I've looked at that the sample category for your primary sample is just usually always orange. I know that's what we've got as default in the model, but I think we should be collecting it a little bit more like if it's a composite, then your category is a composite. If it's a resplit, then your category is a resplit. If it's a 1 meter sample, then your category is 1 meter or 1M or whatever you want to call it, rather than just the bog standard original. And then we have a method. This is the one that's most often not recorded because it's a non-required field. And we've had to do that, I guess, in terms of because we have so much legacy data. I suppose we could make it a default of NR, so if there is no method, but I don't like defaults either because it can make people lazy. So, you know, you've got all your different types of methods, and these should be as specific as they can, like riffle, but if it's riffle 7525, I prefer to even make it that distinct type thing. And then you've got a sample type, which is your physical sample type. So, you know, quarter core, half core, chips, etc. Another thing that should, in my opinion, always be recorded is your sample condition. It's really important to know when a sample is damp or wet because of potential contamination up and down, samples above and below. So especially, you know, drill samples. The other stuff that Table 1 recommends that is variably recorded is the sample date, who took the sample, the recovery estimate. We have it as a percentage in our model, but a lot of clients also will have a recovery code, you know, good, poor, moderate, whatever. And the weight. The weight is actually really important. It shows how it shows the effectiveness of the cyclone, I suppose. I mean, if you've got a 20 kilogram bulk sample and you're 25%, you know, coming out at 7 kilos, then you're getting a lot more sample than you're supposed to be getting. And if it's down to 2 kilos, and you're getting a lot less sample of what you're supposed to be getting. These do not get recorded very often, and they're, you know, part of Table 1's data to collect. The QC samples are almost identical to what I just talked about, with the additional thing of recording what the QC category, whether it's a field duplicate, a resample, etc., etc. Other than that, all those the information that I spoke about is also just as critical to store how the sample was collected. So that's the method, the type, whether the sample was wet, dry, etc., and the date and who sampled it. And I would recommend weights as well. If you've got 2 field duplicates and one is 5 kilos and one is 2 kilos, well, they're not going to be very good comparisons. The other third sort of sample collection that's done usually, and I am talking mainly about drilling here. The surface geochem sampling, we're not so rigorous on QC field collection. It's usually just an indication of what's out there. But, you know, I still think it's probably, especially if your geochem sample's a big sample, recommended collecting some sort of duplicate every now and again just to check. Standards. So we have mainly certified reference materials and blanks. Some clients have quartz flushes, which I'll talk about a bit more about all the differences in a minute. The biggest thing is making sure that all your standards are stored correctly and well labelled. And by stored correctly, out of the wet, out of the light, out of it, especially if you've got oxidizing type standard material, leaving it out in the sun is going to affect it. Going to affect it greatly. Again, with the standard, it's important to record who inserted it, so the sampler, and not so critical about the weight, but sometimes if you've got your own field blanks that you've made for yourself, it's quite important to record the weight and of course the date. And just a thing, just because I'll show you as we go down a bit further, some of the things I've seen in terms of the CRM ID should be exactly as it is on the certificate. So if it's got a space, have the space. If it doesn't have a space, don't have the space, etc., etc. You know, there's so many ways that the same standard has been recorded, and it should just have the same ID, full stop. Okay, now we come into the nitty-gritty. Once you've collected your sample and you recorded it all, how you've collected it, and you've got that, now we've got to send them to the lab. This is the biggest missing link in most of the databases I see. The dispatches are not recorded in the database. Everyone's got Excel spreadsheets and all sorts of things like that that record the dispatches. we have a really good sample dispatch system in the MDS. We have a new sample dispatch extension, I guess, in the latest release of Datashed 5, which hopefully will make this a lot simpler to do. And it's one thing when I left maxgeo a couple of years ago, I worked with some other software packages, and this is the part that I could see was a real improvement on what we originally had. The sample dispatch system that I worked in was really, really good. Anyway, back to the sample dispatch. So the sample's been collected. All the core and the samples are at the core farm. They're bulked into a dispatch to get put on a truck to be sent to a lab. We have all those phases. We have tables to record all of this in, and then you should create the dispatch digitally so that it gets sent to the lab in a digital format. So there's no typo type issues. Like it used to be that you'd send a PDF of all your sample and then they'd have to write them in and stuff like that. And I'm sure everyone here has had experience of a 0 becoming an O or an O becoming a 0. That's the most common sort of a thing. And so the dispatch is created, the samples are collected by or dropped off by someone, and then the samples are received by the lab. That is the dispatch workflow, and that stops there. So I think I would like to implement something that a dispatch has to be recorded prior to assay results being received. Like if you haven't created the dispatch, then you can't load the assay results. That's just a wish list for me. And it's really important. We need all the dates recorded. If you want a true representation of lab turnaround, you need the sample date, the dispatch date, the consignment date, the lab receive date, and then the lab job date. That's the only full chain of custody that you can have. And like I said, usually sample date is recorded here and there, and then we've got a lab date. That's usually the only two things that are in most things, and all that middle bit is often forgotten, or not forgotten, but not loaded into the database. The data's there, it just hasn't been loaded. And then once the lab has got the samples, they do all their bits and pieces, and each lab does everything differently. And most labs here in Australia anyway are reputable, and they do the right thing, and they're pretty thorough in their QC processes, and so it's not too bad. But the samples will be received, and hopefully on the dispatch the instructions for the pulp and reject disposal is included, so the lab knows what to do, whether they're going to throw them out or keep them for a period of time or send them back. The samples are entered into their system, hopefully, like I said, from an electronic copy, so there's no data entry having to be done. The samples are always weighed and prepared. Those weights are just done by default, and if you're not getting those weights in your assay files from the lab, request them, because they do it. It's always. And the other thing I like to request, because they also do this, is your sample sequence. I think that's really important, especially for standards. If you want to know where your standards are, they might, some labs do all the standards at the end. Some labs keep them in their sequence as they're supposed to be and stuff like that. So getting a record of your sample sequence is really critical. I mean, these are things that shouldn't cost you any extra to request from the lab. And then, of course, they do their own QC, their lab QC, and they do QC at the sample prep stage as well as the analytical stage. And that's just an understanding from the lab of where they do it. And I've got an example of of a particular lab's workflow just to show you. You can request these from the lab. They should be able to send it to you in a PDF. And then, of course, all the assaying is done with all this wonderful instrumentation they have. And then the results are reported, and you can either retrieve them yourself if you're using ALS WebTree, for example, or they're emailed to you, or however you get them. An example of it's very hard to read, sorry, but this is an example from Genalysis back in the day when it was Genalysis, of just how their system of where they took the field prep versus the analytical prep, and the size, and how much of the sample, what the size of their little sample that they're assaying, all that type of thing. Okay, then we've got the assays. So the next part of the process and the sample and assay processing is that we've received, and in this case, I'm referring to our AAL that we have, which is the automatic assay loader. All of our hosted clients have this, and quite a few of our on-premise clients have requested and got this implemented. So Datashed assay merge, obviously assay loading is pretty easy to do. You can do one file at a time, you can do multiple files. and that's fine, but this is just the automated part of that process. So you've received the results, the assays are merged or attempted to merge, and a whole lot of things get involved in here. While it's trying to merge, it checks for things, if it can find the sample matches, if there's missing methods and elements in the libraries, if there's missing conversion. You've got more than one sample match, which means you've got the same sample ID in 2 different data sets, and you've got both data sets turned on. It'll say, I don't know which one to map it to. So you'll have to turn off the one that it shouldn't be going to. And in some instances, not so much now, but invalid results, and where it used to be that if clients would put a little asterisk beside anything that was greater than, say, 1 gram per tonne gold, just to show you, hey, look, I'm good, I'm high, I'm a good result, look at me. Of course, that stops the merging, any little characters like that when it's expecting a number. We also have our QC rules. If you're using Datashed 5, which is basically a little set of rules which tell you whether a batch is going to pass or fail based on what percentage difference you want for field duplicates and how many standard deviations from the expected value you want for standards, etc. They're all customizable. We've got a default set, but completely can be changed to whatever is more appropriate if they're not appropriate for your particular cases. And then we have data masks, which is how the assay system manages lab QC. So you can set up masks for saying that if a check sample starts with CH, then it's a lab check. If your standards are prefixed STD blah blah, then it's a standard and goes into. So it's a smarts around how to automatic load all the lab QC. Hopefully, any issues, if there were any, are resolved. And then you know, if you're getting constantly failed batches, that's obviously a flag to look at your rules, and maybe in you know, if you've got a high nugget type deposit and stuff like that, instead of 2 standard deviations, you're up it to 3 standard deviations as an acceptable rule. Just things like that. Then once then that goes into table assay, and that's all great. That's your normalized assay system. It's not really easy to use in that way. So we have what we call assay ranking into a flat table. That requires a whole lot of attributes to be set up for all the elements that you want to see, and you can also set up, and by default we just have the highest ranked method goes into the element field, but you can also set up static attributes, which if you want to look at, I'll use AU as an example. AU by fire assay, AU by ecoregia, AU by whatever method you like. We can set up attributes to show you all of those as well. And then, of course, once it's in the flat table, we have a series of views that join each of the individual sample tables to the flat table to give you your assay views, which you can look at, and they look, you know, they're much easier to look at, and they also usually what is used for exports and for sending for further manipulation, whether you do resources, etc., etc.
Any questions?
Yeah, please stop me if you've got any questions. Now to the nitty-gritty of how the actual assay system works in Datashed. We have what are called left-hand tables, right-hand tables, and assay tables. The left-hand tables are simply the sample tables. So your left-hand table is, and you can have many to the one right-hand. So as you saw, we've got multiple sample tables, but they all go into TBL assay. And this is DH-SAMP, PT-SAMP, FS and LS SAMP. The PXRF, hyperspectral, and water, obviously completely different systems, but they work exactly the same way. So your right-hand tables are your assay tables. We've got table assay water, table assay, hyperspectral, etc., etc., and it links to the associated flat table via dataset sample ID, much like the left-hand sample assay tables matched by exactly the same dataset sample ID. The right-hand table part of Datashed is also where you set up your attributes. So those of you that have got Datashed on-premise, you'll be very familiar with all of this. And then we have assay tables, which is a bit of a misnomer because it's actually the sample register. But it's what happens when you load a sample is that the sample register automatically gets populated with the dataset, the sample ID, and the table that it's going to. So TBL DH SAMP, TBL PT SAMP, etc. That goes into the sample register, and the sample register uses that to process the assays to go into the flat tables. So it doesn't use the individual sample tables, it uses the sample register. And then we come down to probably how the assays are handled. And we have lab methods and generic methods. Each lab has its own unique code for the same thing. So that's why we have generic methods. Basically, all it is that it's a conversion of individual lab methods from individual laboratories to a single consistent same generic method. A fire assay is a fire assay. You know, that type of thing. We are finding as you know, as technology gets better, that there's a whole lot of new methods coming out. So they're constantly evolving and our priorities are constantly changing with them. We're working on a system where you can insert a priority and it auto, well, we've already got the stored procedure to be able to do this, but we'd like to make it a bit easier to manage, where you, if you insert priority above, it moves everything else down one. So rather than having to go and change everything first and then try and find a space where you can put a new method, because all the new methods are very accurate, so they need to be quite high up in the priority list. And we've used a lot of those numbers already if you look at our default priority library. The other thing is priorities can be different for different styles of mineralization or different deposits. Just because by default we're saying fire assay is better than aqua regia, it may not suit some deposits, and you can change that. That's the important thing to take from here. The same thing as lab elements versus elements. We convert a lab element to a single consistent element. Most of the time labs, this is not a hard one. AU is AU and copper is copper and lithium is lithium, etc., etc. This is also where we define the system units. In this element table, that is where you say what your preferred unit for that element is. What you have to be aware of is if you change that in that table, you then have to remember that you'll have to add a conversion to your attribute if you keep the column in your flat table. So if you go from ppm to percent, but it's still ppm in your flat table, you need a conversion. And then we've combined the elements into element groups for priority reasons, because sometimes some element groups can take slightly different priorities than others. And then we have units and conversion factors. Labs are great and everyone's great about converting things from, you know, gram is G, GM, GR, grams, etc. And then we have funny ones where you've got no unit for things like SG, which is a bit weird because it actually does have a unit. And you've got, when we have to have a conversion, at a minimum, each unit needs a 1-to-1. So gram to gram, unit conversion of 1, ppm to ppm unit. And we've come, our model comes with a whole lot of pre-done conversions in there, and every now and again you'll have to add some new ones. And just as a note is that water has the same assays for the same elements as our normal wet chemistry, and milligrams per litre is the equivalent to ppm, so you need that 1-to-1 conversion in there as well, because the system unit for in most of ours is ppm. Proportional assays. This is a good one. This is, people still get this wrong, and they can be difficult. But we have, I'm sure most of you have heard of screen fire assays and leach well, the two different types of proportional assays that are around. Screen fire assays mainly applied to coarse gold particle deposits, but they're not appropriate for where the fine fractions are highly variable in grade. They're expensive. The sample is split into coarse and fine fractions for a defined screen size, typically 75 microns. And then the total AU is a weighted sum of all of those fractions. Leach well works exactly the same way, except it's obviously not fire assay, it's a cyanide leach, hence not being appropriate for clay-rich deposits because it doesn't dissolve all of that very well. It's much cheaper to screen fire. Again, they do coarse fractions. They don't always analyse the fines, but if they can, they should. And AU again is determined by the weighted sum of the two fractions. So without going into the maths, it's just a calculation of your weights and your grades all over the total weight. And then in some cases, as you can see here, because the fine fractions are really quite difficult, they'll take 2 or 3 results of these and then do an average of the 3 to be your minus fraction. Same The equations are both the same. It's just that we've got an average of the minus fraction.
Can I interject here?
Yep.
Question. We make the labs do all that calculation so that it comes out as part of the certification rather than.
Yes, absolutely.
in the
Yeah.
database.
99% of the time, the AU total is they provide it for you already. This is just explaining how it's done.
Okay, I just thought maybe you were advocating that we should do it local, in which case I wanted.
No. The 99% of the time the labs do it. Yeah.
Thank you.
Okay, so this is what should be mapped for your proportional assays. You have a total weight, you have a coarse fraction weight, you have coarse gold weight, you have a coarse gold grade, a fine gold grade, and then your total gold, which is your calculation that we just discussed previously. The number of times the plus and the coarse fraction, the coarse and fine fractions of gold get mapped to AU as the element is huge. I saw it in a database yesterday. So all these coarse and fine fractions were not mapped to AU plus and AU minus, but to AU. And so they'll all have a generic method of screenfire assay. So it's random which one datashed will pick and put in your final grade. And it's the same with the weights. Like a lot of the time, the plus weight and the total weight are just mapped to weight, but it's not. One's a total weight and one's a plus weight. Obviously, they are different elements. And it's the same. I'm not going to go through it again with Leachwell, but it's pretty much exactly the same thing. So yeah, so a lot of this is still, finding a lot of these issues still existing in current databases. And here's an example of the type of file that gets presented from the lab. So you've got, that's your calculated one that they've already done for you. You've got your coarse gold, your fine gold, then you've got your gold weight, and then you've got your, so it's a bit hard for me to see, that's your coarse weight and your fine weight. And then for good measure, they've obviously assayed gold by traditional methods like aqua regia, et cetera, and gravitational. It's quite interesting to see that the aqua regia results obviously above detection for what they can handle, but even the gravimetric method said it was over 200, but the screen fire was 651 for that particular sample. For the low grade one, it works perfectly well, 0.24 and 0.24. So it's thereabouts. So it's when they're really high is where screen fire has its benefits.
I just stop you there because I actually get results like, and those AU results for the AA 26 and 26D, they're actually on the minus fraction. But the way the lab reports it, I have to go and do a little bit of manipulation to get it how I want. So you'll see the 0.22 and the 0.24, if you average that, you get 0.23, which is the AU minus fraction grade there. So with some of that stuff where you're saying it's going wrong into the database, it's because the way the lab is reporting it causes the issue.
Yep. Yeah.
Like that AU for the 26, that actually should be AU minus, I think.
Okay, that's not my understanding. This is, to me, it's just AU by aqua regia, and then this is a duplicate of it, of the same result.
I've gone and had a look at their documentation online. And I'm pretty certain that those two columns are on the minus.
Okay, it's hard to tell for this one because, I mean, it's close to this as well, the total as well as the minus fraction. So I'll have to review that, but yeah, but this is definitely a different method, and I'm pretty sure it's not the fine. So, but it's yeah, I can look at that. I'll have a look into that. You might be right, actually.
Yeah, because the ALS ones caused me quite a bit of grief because.
Yeah, the labs, they need to get, this is where they get it wrong here in the element. And we've had quite a few discussions with ALS in terms of you can't put the element or the description of the element, whether it's fine, coarse, in the method name. It has to go in the element name. So yeah, it is an issue. Correct.
Isabel here.
Hi.
Hi. The other thing to watch out for with this is with the historical data in the assay file. Quite often the lab just doesn't bother reporting half of it. So
Oh, correct.
You
Yeah.
have no idea what's going on. So, it's really important for them as they can't go back to the lab. Say,
Absolutely, yeah.
"Let me see the field."
Yep. No, I agree. Yeah. His historic data can be really, when all you've just got is like screen fire assay as a method and you don't even know what's the total, which is the fine, which is, yeah.
But really, you're second guessing the lab.
Yeah.
The only field in that whole set that you need is your AU total and the weight. Everything else is lab stuff.
I've actually had labs that don't actually give you the total.
Well,
They just give you the AU and it's actually the.
we've had them try that. We send it back and say,
Yeah.
we need
No,
you
no,
to certify the
but
total.
if you don't know, people just assume that it's their result and they put the force point in as the goal. Because the lab doesn't give them a calculator. So you have to ask them.
Yeah. I like all of the fractions because I like to do every now and again a random check to make sure that their calculations are correct. But that's just me. So, but the lab reports that we should record it is my thoughts. Exactly like, all labs will take a weight and generally they'll have a lab sequence, and I think they should be in these files too, 100%. Okay, now we go to the fun part, standards and all that. CRMs are usually supplied from certified providers and in bulk. We're finding more and more often, particularly with the ORAS standards, that the clients and labs are purchasing the same standards. This, of course, gives us a bit of a headache in terms of trying to split out client standards from lab standards. I'll talk about that in a minute, but some labs also create their own internal reference material. Trying to get the expected values from them for some of these has been a headache over the years, and especially when we come to some legacy data that Isabel was referring to. We get all these standards and we just can't find what the expected values are, and it effectively renders them useless. You can't analyze them. Standards should be selected for the appropriate deposit and elements that you're interested in. You just can't use one standard across everything. I mean, they're specifically created for specific purposes. I spoke before about standard IDs needing to be consistent, and they should be the same as what is on the reference certificate, and they're usually inserted at regular intervals. Same for the blanks. They can be purchased or created. A lot of companies will compile their own blank from waste material or sand or all that type of thing. Those type of blanks can actually return some fairly variable results, especially if they're not crushed or mixed correctly. Again, blanks are typically inserted at regular intervals. I also like, if you're not using a quartz flux to the right, which I'll discuss in a second, I also like manually inserting blanks after ore grade material just to give the lab a bit of a test. I think this is important. Quartz flush is usually the best option to put at the end of a mineralized zone because it's a clean blank of sorts, because it's usually made from barren quartz material. So you know that it's zero. Well, it's not exactly zero, but should be around zero. And like I mentioned, it's typically inserted after identified ore zones to test for smearing. In terms of acceptance, standards generally are accepted from two standard deviations from the expected value. I mentioned before, coarse gold, for example, 3 standard deviations sometimes would be more acceptable because of the variation. And you also don't have to use standard deviation as your you can use high and low, which is your 95% confidence limits. RockLab standards, interestingly, recommend using these rather than the standard deviation. So it's important to have a read of these certificates initially, at least initially, and work out what's the best way of recording the information for your QC checks to be done on. I found over the years experience that the outliers can highlight some issues, but 95% of these are mislabeled standards, where the wrong standards have been labeled incorrectly when they've been created in the little envelopes, or people just blindly pulling them from their buckets or not not reading what the standard ID is correctly. The blanks are typically, we expect them to be either below detection or around 0, and often a blank is only appropriate for your primary commodity. Like if you've got a gold blank, well, then you can't expect it to be blank for all the other elements, because it's not made for those other elements. It's only a blank for gold. So that's something to be aware of. I mean, I have a client where I do quarterly QC reports for them, and I do it across 6 different elements, and the blank is only for the primary element. The results it does for the others is like they're hugely anomalous, so it just doesn't work. Okay, just some of the issues that I've identified, and please stop me if you guys have got war stories of your own. Standard IDs is a classic. I've used ORAS 215 an example. The correct method is the second one, which is ORAS space 215, but it goes in without a space. It goes just as 215. It goes with an STD in front of it, etc., etc. And it doesn't matter what the lab calls it. If it's a lab standard, it should always be converted to the correct standard name. Not what the lab calls it, but in the mask when you assign the standard ID. A lot of the time, standards are not allocated the right standard type. Like people aren't defining what is a clear client CRM versus a lab CRM, etc., etc. The supplier's not recorded. It's most days we know where they've come from, ORAS or Rock Labs or Amos, all that type of thing. Expected values, like as long as there's standard IDs in the QC reference table, it seems, a lot of the time it seems to get forgotten after that. I mean, obviously that wouldn't be happening when you're actually doing QC, because you'd know you wouldn't have expected values and you would have gone and hopefully inserted them, etc., etc. But what I find is that a lot of the time it's just random methods allocated to the expected value, but it should only be the method that's on the standard reference certificate. And that's one thing that quite often when you do have anomalous standards or standards that are failing, it's because you're looking at a 4-acid expected value and you're comparing it to a fire assay result. It's going to be different. So yeah. A lot of the time I find the standard deviations or the upper and low limits aren't entered correctly. Like the standard deviation is only one standard deviation, and I've seen people put multiply it by 2 and put it in as a standard. So then by the time you're looking at 2 standard deviations, it's actually 4. And the high and low, the 95% confidence intervals does actually map to our high and low fields in our QC reference value table. And the incoming data masks, this is a big one, not set up correctly, especially when you've got, when labs don't make them unique, it's just like blank and then blank, blank, blank. You have to make sure it's each one's going to overwrite each other if you don't, put at least the batch number and the row number appended to it to make it a unique value. I'll show you some examples of what happens when that doesn't occur. Just some examples. The top left is just an example of where you've got blanks, 2 exact same things, but one's the full name and one's BLK, and then you've got 3 different versions of saying course blank. It's one standard, so it should just go in. It doesn't matter what the lab calls it, because again, it should just then convert to the one. If it's a blank, then it converts to standard blank. And I mean, I prefer a little bit more discernment than there, where you've got a lab blank versus a client blank. So, that type of thing. The next one down here is just like, these aren't the correct standard names. They've got an STD in front of them, and some have got underscores and some have got no spaces, and etc. An example of a single database is where you've got the standards inserted twice, except they're just slightly spelt differently. And this one here is just an example of the top one, ORAS 13B. They're both apparently lab standards. I mean, our typical way of denoting it when a client and a lab are using the same one is to put the lab prefix, suffix to identify, and that way you can clearly identify which is the lab one versus the client one. And in this particular example, the standard ID, actually the alias is correct, but the standard ID isn't. And here's a classic example of where a unique, this particular standard wasn't set up in the masks to make it unique, like this is not ticked as non-unique. So as you can see, each time the standard comes in, the preferred just keeps getting bumped up. So although there should actually be 140 of these results, there'll only be one. And the last one will be the one, you know, the 0 will be only one that's reported, because each time you've loaded the same standard, even though it's from a completely different batch, it's just overwritten the previous one. That's the importance of setting up these masks correctly. And that's me done. So hopefully got some questions.